Classification of amplifiers. Under this classification of amplifiers, uh, type of signal, based number of stages, type of configuration, classification based on conduction angle, frequency of operation, small signal, large signal, single stage, small signal having single stage, number of stages, common emitter configuration, classification based on conduction angle, here class A amplifier, frequency operation, direct current DC, frequency of operation. Second, multi-stage, large signal having multi-stage, it has common base, class B amplifier, audio frequencies, here frequency of operations, and in common collector configuration, class AB amplifier, radio frequency. Under class C amplifier, classification based on conduction angle. Under class A amplifier having VHF, UHF and SHF frequencies. Different regions of operation. Region of operation, emitter junction, collector based junction. Under region of operation, cutoff region, active region, saturation region. Emitter based junction, under emitter based junction, reverse biased, forward biased, forward biased. That is cutoff frequency operation, emitter based junction, reverse biased, collector based junction, reverse biased. In active region, forward emitter based junction, forward biased, collector based junction, reverse biased. Region of operation, in saturation, emitter based junction having forward biased, collector based junction having forward biased. Transistor voltage specifications for various operating regions. Transistor Si silicon germanium, VCE saturation 0.2 volt silicon, and VBE saturation voltage for silicon 0.8 voltage, VBE base and emitter active for silicon 0.7, for VBE cut-in range for silicon 0.5 volt, VBE cut-off for silicon 0 volt. In germanium, VCE saturation at 0.1 volt, VBE saturation at 0.3 volt, VBE active at 0.2 volt, VBE cut-in at 0.1 volt, VBE cut-off at minus 0.1 volt. Condition for active saturation regions. For saturation, IB is greater than IC divided by beta DC. Base current proportional is greater than collector current divided by beta DC. Condition for active and saturations. This is the for saturation region. IB base current always greater than IC. For active region, VC is greater than VCE saturation. VCE greater than VCE saturation region. Here in saturation region, base current always greater than collector current. That collector current under divided by beta DC. In active region, VC always greater than VCE saturation, that is common emitter voltage, is greater than common emitter saturation. Operating point near saturation region gives clipping at the positive peaks. Operating point near saturation region gives clipping at the positive peaks. 0 to VC here in x-axis common emitter voltage. In y-axis collector current. Here that is operating point in near saturation region gives clipping at the positive peaks. Here, 1 minute. Here x-axis common emitter, y-axis collector current. In here, in when IB equal to 0, base current is 0. This plot we got. When IB equal to 1, base current. Operating point near saturation region gives clipping at the positive peaks. Omega t. Here. Operating point near cutoff regions gives clipping at the negative peaks. Here. 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 Okay. Operating point at the center of active region is most suitable. Operating point center active region is most suitable. Here. Okay. Transistor biasing. Here fixed bias circuit. Fixed bias, this is common emitter. So VCC base current in RB resistor, IC current source in RC resistor, IE dropout in ground. Fixed bias circuit. This is the fixed bias. Voltage divider bias circuit. Here in this common emitter configuration, emitter to collector VC voltage, emitter to base VBE voltage dividing here one voltage, here one voltage, VCC applying source voltage, base connected in between R1 and R2, collector connected to VCC through RC, emitter connected to ground through RE. IE emitter current flow, collector current flow this direction, I plus IB, base current plus I. Here I only draw flowing in R2 resistance. In common emitter, common collector, common base amplifier. Practical common emitter amplifier circuit. Common emitter, here emitter, common connection is there. Parallelly, common emitter capacitor for charging, recharging, charging, discharging purpose. VCC connection. RC through RC connected, parallel C2 capacitor connected outside the load resistance. INC to other end connected R load resistance. R1 connected in between VCC and the base and the capacitor. C1 connected here, source voltage, signal voltage, sorry, signal Vs. So RS signal resistance, R2 connected here. This common connected. Here common emitter amplifier circuit, here common collector circuit. Common collector. Okay. This is RL, external load V0, V2, VG, VBE, emitter resistance VB, R2 resistance V1 dash, signal source, capacitor C1, R1, VCC. Common base circuit. Common base here, common in between input and output connected, common base. Here voltage source connected in base emitter side, yeah, emitter and ground, source resistance, load connected to source resistance and the capacitor C1. In between here V1 showing, VI showing. Here supply source, also here also VC, sorry, DC source voltage is there, connecting here battery. So RE through RE connected to emitter. Here IE current flow, I this direction, emitter current, IC current direction, this direction. So in this output circuit, IL, RL, before that C2 for capacitance purpose, output voltage, charging, discharging. Here VCC source connected, RC, common circuit. H parameters representative of an amplifier. In this H parameters representation of an amplifier, transistor amplifier. Here input IN, I VI input voltage, I out, IO output current. Here I V out voltage output, VA equal to, this is H1 on I1, H1 on I1 hyper II H12 V0. Here I0 equal to output current equal to H21 I1 II input current plus H22 V output voltage. Definition of H parameters. These are H parameters. The parameters in the above equation are defined as follows: H1 on VI that is input voltage divided by input current. Input resistance with output short circuited in ohms. Input resistance. H parameters nothing but resistance only. So with the output short circuit in ohms. Here H12 fraction of output voltage at the input with the input open circuit.